Oceans cover 71% of the planet. And beautifully blue though they may seem, throughout most of history, humans have found them rather tricky to explore, which might explain how they ended up naming a planet that is quite obviously covered in water, the Earth. But despite these early difficulties, millions of tons of raw materials, food, goods and people now traverse this blue expanse every day. Without the roughly 100,000 ships that carry this cargo, the modern human world would grind to a halt. But moving all that stuff requires a lot of energy, and at the moment almost all of that energy comes from polluting fossil fuels. Today, shipping accounts for around 2% of global carbon emissions, and without action, that could rise to 17% by 2050. So how can humans reduce the environmental impact of this essential ocean trade? What is the future of shipping? For thousands of years, ocean shipping has carried the lifeblood of civilization. From the sleek galleys of the ancient Phoenicians to the gold-laden galleons of the Spanish Empire, nations have risen and fallen in the wake of maritime trade. But the real game-changer arose in France in 1783, when Frenchman Claude de Jouffroy whacked a steam engine on a boat to create the first steam-powered ship. Traveling faster and farther than ever before, steamships soon revolutionized global trade and cleared the decks for the massive container ships of the present. Today, a vast network of shipping lanes connects the world and forms the backbone of the global economy. It allows aluminium from Australia and copper from the Congo to be shipped to Shanghai to assemble solar panels that are sent to San Francisco. Unfortunately, unlike Claude's little steamboat, the modern behemoths that carry these goods rely on enormous engines that guzzle up vast volumes of fossil fuels. Every year, the shipping industry consumes a whopping 2 billion barrels of oil, enough to stretch to the moon 4 times, and it pumps out more CO2 per year than Germany. In fact, shipping fuel, known as bunker fuel, is some of the dirtiest in existence. It's notorious for producing toxic pollution like sulfur oxides, nitrogen oxides, and particulates, as well as copious quantities of carbon dioxide. So how can humans wash away the emissions of ocean trade? Well, there are 6 ports of call on the route to sustainable shipping. The first method is called slow steaming. This simple strategy is widely used around the world. Due to the density of water, fuel consumption rises exponentially with speed, so slowing down by just 10% can reduce fuel use and emissions by nearly 30%. Unfortunately, slowing down isn't always practical due to delivery schedules and profit margins. So the next solution is to improve the design of the ships themselves. Marine organisms like barnacles and seaweed increase drag on a ship's hull. So by cleaning regularly and applying anti-fouling coatings, ship crews prevent them from attaching. When sailing through the open seas, the smooth, barnacle-free hulls lower both drag and fuel consumption by up to 10%. Hull shapes are getting smarter and more streamlined, and some ships use air lubrication systems that pump a layer of air bubbles beneath the hull to minimize friction and reduce drag even further. When port sizes allow, replacing smaller ships with larger ones is another
tactical approach.
With economies of scale, larger ships can cut fuel consumption and emissions per container unit by up to 30%. Another ingenious strategy is inspired by the sailing ships of old.
Shipping companies are fitting enormous wing-like sails on cargo ships to reduce the need for engine power.
And special spinning rotors, called Flettner rotors, are being used to harness something called the Magnus effect, which uses the airflow of the wind to create a pressure difference that generates extra thrust. Some ships even use kites to harness high-altitude winds. All reduce the need for engine power and can cut fuel consumption by up to 30%. But there's an obvious solution staring humanity in the face. A little-known fact is that around 40% of all the cargo that's shipped around the world is actually fossil fuels, which means that using less coal, oil and fossil gas and more renewable energy on land can significantly reduce the number of cargo ships needed at sea. Fewer oil tankers also lowers the risk of oil spills. It's a win-win-win. But even if humans sail their ships more slowly, engineer more efficiently, and ship less coal, oil and gas, powering ships with fossil fuels will always create CO2. The obvious answer is electrification. After all, it works for cars, so why not ships?
Well, fully electric cargo ships are already in use for short distances in places like Norway, and a recent study has shown that up to 40% of all cargo shipping could be electrified.
But while this would work for short to mid distances, for long distances, batteries are not practical. They can be used with conventional engines in a hybrid setup, but using batteries alone would take up too much of the cargo storage capacity, which is impractical and expensive, so other solutions are needed. Alternatively, humans could replace bunker fuel for a different type of fuel. Some shipping companies have changed to a form of fossil gas called liquefied natural gas, or LNG, which can virtually eliminate toxic sulfur emissions and reduce nitrogen oxides by up to 80%. But because it's still a fossil fuel, it only reduces CO2 emissions by about 20 to 30%. Worse, LNG experiences methane slip, where unburnt methane gas leaks from ship engines directly into the atmosphere. Over 20 years, methane has over an 80 times greater impact on global warming than CO2. So, over the crucial next 2 decades, LNG will be just as bad for the atmosphere as bunker fuel. Clearly, a better solution is needed.
Enter biofuels. In theory, these can be carbon neutral and are replacing fossil fuels in some ship engines without the need for significant modifications.
Problem solved, right? Well, not exactly. Obtaining biofuels can lead to deforestation and carbon emissions as land is cleared to grow the crops needed to make them.
But by using sustainable sources like microalgae or seaweed that humans are carefully cultivating to ensure carbon neutrality, biofuels could become a powerful tool for decarbonizing industries like shipping and aviation. A better long-term option could be to power ships with green hydrogen fuel, which is produced by splitting water into hydrogen and oxygen with electricity from wind and solar power.
This can either be used as liquid hydrogen, which has to be stored in super-cold cryogenic containers, or it can be converted to liquid ammonia or methanol fuels, which are much easier to store. This change in fuel could cut shipping emissions to almost zero. But green hydrogen production would need to be ramped up quickly, which is easier said than done. A final long-term option could also be on the horizon: nuclear-powered shipping. Recent breakthroughs like small modular reactors and molten salt reactors have renewed interest in nuclear-powered container ships. In fact, the nuclear ships of the future are already being designed. So, can humanity clean up the shipping industry once and for all? Well, the United Nations and the International Maritime Organization seem to think so, with a goal of reaching net zero emissions by 2050. To keep tabs, they are using the carbon intensity indicator to rate how efficiently ships limit CO2 emission. But just measuring progress won't cut it. The long-term shift requires scaling up renewable energy like wind and solar to produce green hydrogen, ammonia, and methanol. Along with biofuels, these are key to replacing the fossil fuels powering ships today. In the short term, reducing fuel consumption through slow steaming, improving ship design, wind power, and electrification is essential. It won't be easy, and it won't happen overnight. But with the inevitable progress of humanity, the future of shipping will be green.
Please spread the word about climate change solutions by sharing this video, and like and subscribe if you would like to see more. Thank you.